There are two ways to gather data, observation and experiment. And this cartoon illustrates something really cool about the differences between these two ways. I used to think correlation implied causation. Then I took a statistics class. Now I don't. Sounds like the class helped. Well, maybe. Since it wasn't an experiment, did it cause it? I don't know. So, um, let's look at something I've been always trying to do, and that's improve student mastery in my classes. And I thought that using automatic grading of classwork could improve it. Um, there were a couple of reasons I thought, well, they'll get faster feedback. They'll get accuracy on the grading so that they'll always know if they got something right or wrong. So how could I go about checking if this would actually improve the performance of my students? Well, I could look at what's already out there in the wild, all right? So there are two types of observational studies. One is retrospective. So basically, I'm looking back in history and saying, okay, how have kids performed in the past with automatic grading? Or look at prospective, say, hey, let me start tracking kids and look at how they do with automated grading. It can be used to discover trends and possible relationships, but it is not possible to demonstrate a causal relationship, and we'll talk about that in a sec. So if I was doing a retrospective study, I could look at the data for the subject available from district DCAs and compare the performance of those who were graded automatically to those who were graded under more traditional systems. And some of the challenges I would face is that the district data does not include the grading method for daily work. For the DCA, it's all automated, but for the daily work, it doesn't include that. And not only that, teachers who use automated grading technology may be different from teachers who use traditional grading methods. Not to say they're better or worse, but there could be actual differences. All right, so this cannot be used to establish causation. That's the other challenge with this, is I can't say, oh, the automated grading actually did cause an improvement. Okay, so for a prospective observational study, if there is no existing data or automated grading is not known, I could say, well, let's go ahead and start tracking. Well, since they haven't been generated yet, now I can say, okay, I'm going to go ahead and pick certain classes, and I already know what kind of grading method they use, and just grade a sample of that, right? Here's some of the challenges still. One, there might be a difference between the teachers who do automated grading, because you can't just tell a teacher, oh, go use automated grading. It's not a simple thing. Also, I still can't establish causation for this. All right, so what's the deal with causation? Well, it has something to do with confounding variables. Confounding occurs when two variables are associated in such a way that their effects on a response variable cannot be distinguished from each other. Now, in your textbook, you might see the terms lurking and lurking variable, but these are no longer used on the AP test. So just use confounding and confounding variables. So teachers who use automated grading, how could this play into this example that I'm talking about? Well, maybe they're willing to try automated grading because they're already comfortable with the subject they teach. Most times a teacher who's new to a subject is busy trying to get it down right so we can teach it. And we're not willing to do other experiments or try new things because we're too busy trying to learn how to teach statistics, for example, or geometry. Also, a new teacher who's willing to try automated grading might be an experimental type of teacher who also likes to try other things. Like, for example, I have a flipped classroom, I have a next gen classroom, I use Cornell Notes. I'm always trying out new things to see what can improve your performance. So how can we tell if performance improves because of the automated grading or due to some other confounding variable? So let's take a look. This is actually a different study. Does taking hormones reduce heart attack risk after menopause? So in 1992, several organizations, medical organizations, recommended that women take hormones so that they could reduce their heart attack risk by 35 to 50%. And it was based on observational studies that compared women who took hormones with those who didn't. Well, let's see. What could be different Now remember, these women aren't being forced to take the hormones or not take the hormones. They're choosing it of their own volition. So what could be different between these women? Well, women who did take the hormones were also, they found out, they were richer. They were better educated, and they saw their doctors more frequently than the group who didn't. Couldn't that mean that they're just actually taking better care of themselves in general? Because it was based on an observational study, these were all tangled and we couldn't untangle them. So how do we get rid of the confounding variables? Well, we can't use the observational study data. We have to do an experiment. And you can't let the women decide. We have to randomly assign to hormone replacement pills or a placebo. A placebo is basically like a sugar pill. It would be a pill that looks just like the medication, usually. And so you're taking it, because sometimes people, when you give them a pill, even if it's a sugar pill, they automatically feel better. So it's for this psychological or placebo effect. So by randomizing these two things, we can control for the confounding variables. So they went ahead and did a study, and by 2002, several experiments said, guess what? Hormone replacement doesn't really reduce the risk of heart attacks. The reason we saw the therapy was related to heart attack risk, but it did not cause change in the heart attack risk. So the earlier study was confused by confounding variables. So you can see the importance of being able to do an experiment. Experiments are used to investigate possible causal relationships, right? So is hormone therapy related to heart attack, causing change in heart attack risk? Or can automated grading cause a change in content mastery for students? So we need some explanatory variable, the factor. In this case, it's the hormone replacement therapy. For me, it would be the automated grading of daily work. So we apply different levels of the factor to create treatments. Now, sometimes it's going to be very binary. You're just going to have hormone replacement versus placebo. You might have different levels of hormone replacement versus placebo. For me, it's like automated grading or no automated grading. Although I could try different methods of automated grading, but I'm not there yet. All right. Now, each subject or experimental unit is given a treatment. For the study with hormones, that would have been the women. For my automated grading, it was really my geometry students from the 2016-17 school year. The response variable was then measured to see if the differences in treatment explains the differences in response. Okay, so a response variable would be like the actual heart attack risk for the women. For me, I'd be looking at DCA performance. How did they do on that? Now, it does require a random assignment of subjects to treatments. The subjects do not choose. All right. Now, there's another way to get around that, and I'll talk about that with a different type of experimental design. But for right now, we're just going to deal with random assignment. But the main thing is the subjects cannot choose if they receive the treatment or don't receive the treatment. So my poor geometry students last year did not